Hey friends, this is Coding Tiger. Welcome to my channel. If you are trying to improve your coding skills, or if you're genuinely interested in software engineering topics, this is the right channel for you. Today, let's talk about one of the top Google interview questions to evaluate reverse Polish notation. If you're not familiar with the reverse Polish notation, let's look at the Wikipedia. So basically, it's a mathematician notation in which the operators follow their operands. So operators means the typical operations: addition, subtraction, division, and multiplication. And operands basically means numbers in mathematics. And I personally think this is a very genius invention because it eliminates the need of using parentheses in your representation. If you're not familiar with this reverse Polish notation, let's look at the Wikipedia. So basically, reverse Polish notation is a mathematician notation in which operators follow their operands. Operators means just the traditional operations like addition, subtraction, division, multiplication, and operands. In our case, they're just numbers. In my opinion, this is a very genius invention because it eliminates the use of parentheses to represent an expression. Let's look at a few examples in this LeetCode panel to see how the traditional expression can be represented by reverse Polish notation. Let's look at the example. 4 divided by 13 plus 5, and the result will be 0. And it's represented by reverse Polish notation in this way: 4, 13, 5 plus, and then the division. So we have some observations from this expression. First of all, the operation which is evaluated first will always appear in front of the operation which is evaluated later in the array. In this case, the plus operation will be evaluated first and division later, so that reflects in the relative order of these operations in the array. Second of all, when we see an operation in the array, we have to evaluate immediately, and the operands we pick are the two operands which are closest to this operation. So we need a data structure to store the operands as well as the intermediate operation results. Here is how the algorithm looks like. We traverse this token list, and then each time if we see a number, then we just push the number into this array. And then whenever we see an operation, then we pop the last two elements from the array and do the operation and store the intermediate result back to this array, and then continue traversing this token list. And if you notice, the data structure that we should be using is called a stack. Basically, last in, first out. Now we have the basic idea of this algorithm. Let's start the implementation. First of all, let's define a stack array to store the operands and the intermediate operation results. And then we defined another two variables, num1, num2, as the two operands for the operation. Then we go through this tokens list. And we do the switch case. Here is how it works. If the element is plus sign, that means it is an operation. Then we pop the last element from the stack as the operands to the right, and we pop another one as the operands to the left, and then we push the addition, a result, back to the stack. Then we break. Then we continue. If the element is minus sign, then we do the similar thing. I'll just copy this block. Instead, this will be minus, and continue. Let's deal with the case. Where is the star sign? I'll copy the block. And this will be times operation. And the last, not the last, when is the division? Let me copy the case. The division case is a little bit complicated because the requirement is that for the division we have to truncate towards 0. And in JavaScript, the math.flow function, it works well for the positive result, but for the negative result, it didn't work that way. For the negative result, which actually use the math.ceiling function to achieve that result. So in that case, we have to actually determine if is larger or equal to 0 first, and then if that is true, we can use the floor function. If it's not, we should use the ceil function. And the last case is the default case, which means it's not an operation, it's just number. So if just number, then we just push that number into the stack. And don't forget to pass in to convert the string into an integer. Then break. So after this for loop, if your input tokens is valid, the final result of this stack should just contain an element, which is the final result of your expression. But just for sanity check, if it's larger than 1, that means your input is incorrect. In this case, let's just return null. Otherwise, just return the first result of the stack. So let's run the code to see if it's correct. Okay, it was complaining about this. I see. That's easy to fix. Alright, it passes the test. If you find my video useful, please like my video, share with your friends, and leave some comments. Thank you for watching. See you next time.